Alrighty, let's talk about lesson 6 here, paying off loans. We've talked about this a little bit so far, so some of this will seem like review to you. But our targets today is investigating the time to pay loan formula and investigating how the time to pay off changes as you vary monthly payment, principal, and interest rate. So take a moment, open up your guided notes. If you look at lesson 6, you'll notice in the beginning there's some logarithm sections, graphing logarithm. I'm going to skip that, but we are going to be filling out the rest of the guided notes. So skip the logarithm section. I'm just going to let you guys use the online calculator instead of making you do logarithms in your computer, since I know a lot of you guys have not dealt with logarithms before. So skip the logarithms, but you're going to fill out the rest of the guided notes. You'll notice our questions here are very similar to the ones that are on the actual guided notes. Alright, so learning target 1, here's what I mentioned. This is our time to pay off formula. It's actually the same formula we've been using for monthly payments. It is just rearranged now so that we are solving for n. And since n a lot of times ended up being the exponent, the opposite of an exponent can be a logarithm. So you'll see here, we are solving for n, giving us these two logs. And again, since you guys have not dealt with logarithms before, a lot of you guys, I am not going to make you enter this into your calculator, but I wanted to show you what the formula actually looked like. Kind of cool. But we're actually going to use the formula. So look at this for a moment. We're going to fill in the blanks of the problem. So here is the formula. See if you can pick out the parts. How much was the loan amount for? How much was the periodic rate, and what is the monthly payments? Again, if you haven't had a chance, let me flip back here. There's the formula, and you might want to take a screenshot of this and just put this into your notes, your guided notes, so that you do have it. All right, now use that to find these parts. All right, hopefully you found each of these parts. Here they are. You can see Delaney took out a loan for $1,925. That's that one right, whoops. That one right there. Has a periodic interest rate. This is the periodic interest rate. Notice not the APR, but the periodic interest rate showing up here and here. And she makes monthly payments. That's the $114.5, $114.50. Awesome, and I did mention here, just as a reminder, that it is looking at the actual periodic interest rate, not the APR. So just a quick refresher, since a lot of these do have periodic interest rates. If the periodic interest rate is 1.3%, what is the APR? I wanted to remind you of this formula we have. Remember, to find the periodic interest rate, we take the APR and we divide by the number of periods. In this case, these monthly payments are all going to be, well, monthly, so we're going to be dividing by 12. So see if you can determine what the APR is for this one. We know the periodic interest rate is 1.3, so plug it in and figure out what the APR is. All right, hopefully you were able to do that. And there it is. 0.013 equals APR divided by 12. So to find the APR, we're going to multiply both sides by 12. The APR is 15.6%. All right, so the good news. That calculator we've been using, that advanced loan calculator, it'll already solve for n for you given all the information that you input. We have number of payments. That is what we are changing that calculation method to. You put in the loan amount, the interest rate, payment amount, and poof, it'll give you how long it will take to pay it off, or the number of payments needed to pay it off. So let's try an example here. Suppose you buy a TV for $1,999 and you pay $15 a month and the interest rate is 7.3%. How long will it take you to pay it off? Go ahead, use that advanced loan calculator and determine how long it'll take. Alrighty. You should have found that it will take approximately 274 payments to pay off the TV. Handy dandy loan calculator. Let's take this a little further, kind of looking into our learning target number 2. We're going to investigate how time to pay changes as you vary monthly payments, principal, and interest rate. And again, we've looked at this a little bit when we were looking at other ways to use our monthly payment formula. We were kind of investigating how monthly payment changed when you vary different things. We investigated how principal changed when you vary different things. So now we're going to talk about how time changes. That time to pay something off. All right. So remember, on our original one, we had our TV for $1,999, paying $15 a month and 7.3% interest. What if we decide to increase our payment to $25 a month and the interest rate is 7.3%? How long will it take you to pay it off? Think for a minute before you actually put it into your calculator, though. See if you can make a prediction. You're paying more per month. Do you think it's going to take you longer to pay it off or shorter? All right, hopefully you made your prediction. Now go ahead and put it into your calculator and see what you get. Awesome. Hopefully you found that it'll take 110 payments to pay off the TV. Remember, originally 274 payments, now 110. So see if you can make a statement about how increasing a monthly payment affects the time to pay it off. All right. So we've varied the amount of monthly payments. What if we vary the interest rate? Again, suppose we have this TV for $1,999. We again decide to pay that initial $15 a month, but we found that the interest rate is, oops, I put lower, it should be raised to 8.5%. How long will it take to pay it off? Sorry, I clicked the button a little too quick. So make a prediction just like we did before. What do you think? If I raise the interest rate, will it take me longer to pay it off or shorter to pay it off? All right, now try it with your calculator. All right, you'll notice it'll take 408 payments to pay off the TV. Remember, it originally took 274 payments. So see if you can make a statement about how increasing an interest rate affects the time to pay it off. Alrighty. Our third thing we're going to vary is the principal, the original amount we're borrowing. So we decided to choose a different TV model. We're going to upgrade. $2,299. But again, we're going to decide to pay just $15 a month, and our interest rate is back to the original 7.3%. How long will it take to pay it off? So again, think for a moment, make a prediction. I'm raising the amount I'm borrowing. How do you think that's going to affect the time to pay or the amount of payments? All right, so check your prediction. Go ahead and test it in your calculator. All right. Hopefully you found it will take 440 payments to pay off the TV. Remember again, originally took 274 payments. So go ahead, can you make a statement about how increasing the principal affects the time to pay off? All right, here is your exit ticket problem to finish. Giselle took out a loan for $480 at 19.2% APR, compounded monthly, to buy the new entertainment system, and she agreed to make these monthly payments of $16.25 to pay off the loan. If she changes her monthly payment to $31, how much faster would she be able to pay off the loan? Go ahead and finish up by answering this question. Have a spectacular day. Again, good luck to those of you testing. I miss you guys, and I will see you hopefully on Monday.